Hello everyone, welcome to this session on Numpy, identity array and IO function. In this session we will learn what an identity array is and how to create it using np.identityOf, and we will also study np.IO function, understand its different parameters and see how it can create square, rectangular, upper diagonal and lower diagonal matrices. Finally, we will compare np.identityOf and np.IOf to understand when each function should be used. Let's begin with the concept of an identity array. So first we are going to discuss about identity array in Numpy. An identity array is a special type of square matrix. It has two important characteristics. First, all elements present on the main diagonal are equal to 1. Second, every other element in the matrix is 0. So the main diagonal starts from top left corner and ends at the bottom right corner. For example, in a 3 cross 3 identity matrices, the diagonal elements are 1 while all remaining contain 0. Identity matrices are widely used in matrix multiplication and many mathematical and scientific applications. Now, let us see how to create identity array using Numpy. So in Numpy, it provides np.identityOf function to create an identity matrices. Here the syntax is very simple. It can be written as np.identityOf n, where n represents the size of the square matrices. Let us understand this by using the following code. We are working with Numpy, so we have to import Numpy. This was the first statement. Import Numpy as MP. Then I equal to np.identityOf 3. Here we use the np.identityOf function. The value 3, it indicates that we want to create a 3 cross 3 identity matrices. The generated matrices is stored in a variable I. Then print of I. This statement prints the identity matrices stored in I. So this was the output. So see the output, the diagonal remains 1 and remaining things contain 0. Notice that Numpy displays the value as floating point number by default. Then we will be printing the shape by using the shape attribute. So it displays the dimensions of the array. Since it's a 3 cross 3 matrices, so it will be written 3 comma 3, that is 3 rows 3 columns. Now we know how to create an identity matrices. Let's learn another important function called np.IOf, which provides more flexibility. So now we are going to discuss about IOf function in Numpy. The np.IOf function, it create a matrix contain ones on a specified diagonal and zeros elsewhere. Unlike np.identityOf, the np.IOf function can create both square and rectangular matrices. So this was the syntax. np.IOf rows comma columns comma k equal to 0. So here rows, it specifies number of rows, columns, it specifies number of columns. The parameter k determine which diagonal should contain the value 1. If k equal to 0, the main diagonal is selected, that is the main diagonal contain the value 1. If k is positive, that is k is greater than 0, upper diagonal is selected, that is upper diagonal contain the value of 1. If k is negative, that is less than 0, lower diagonal is selected, that is lower diagonal contain the value 1. Let's can understand this better by using the following example. So first we are going to discuss about identity matrix using IOf. Our first example demonstrate how np.IOf create a standard identity matrices. Let's understand this by using the following code. E equal to np.IOf 3. Here np.IOf function, it creates a 3 cross 3 matrices. Since k parameter is not specified here, its default value is 0. Therefore, the value 1 is placed on the main diagonal. The resulting matrix is stored in a variable E. Then print of E. This statement displays the generated matrices stored in a variable E. So this was the output. So the output is identical to the matrix created by using np.identityOf. One important thing we have to note here, when a square identity matrix is required, both np.identityOf and np.IOf produce the same result. Next, we are going to see about rectangular matrix using np.I of. Unlike np.identity of, np.I of, it can also create rectangular matrices. Let us understand this by the following code. E equal to np.I of 3, 4. So in this statement, 3 specifies the number of rows, 4 specifies the number of columns. So here the k value is still 0. So the ones are placed along the main diagonal. The generated matrix is stored in E. Print of E, so this statement, it display the generated matrices stored in a variable E. So this was the output. So an identity matrices cannot be rectangular. However, np.I of allows rectangular matrices by placing ones along the main diagonal until the smaller dimension is exhausted. Next, we are going to discuss about upper diagonal. So if it is upper diagonal, k value will be greater than 0. That is positive value. Now let us understand how the ones are filled in a upper diagonal. So to understand this better, see the following code. E equal to np.I of 3, 3, k equal to 1. So here the matrix size is 3, 3. 3 rows, 3 columns. It's a 3 cross 3 matrices. Then the parameter k equal to 1, it tells numpy to place the ones on the upper diagonal. So this was the upper diagonal, which is one position above the main diagonal. Then the result is stored in a variable E. Then print of E. So this statement prints the matrices stored in a variable E. So this was the output. Notice that all one have shifted one position upward. So this was the upper diagonal. Next, we are going to see about lower diagonal. That is, similarly, we can also place the ones on the lower diagonal. So since it's a lower diagonal, then the parameter value k equal to -1, that is negative, less than 0. So to understand this, see the code. E equal to np.I of 3, 3, k equal to -1. So 3, 3, 3 rows, 3 columns. It's a 3 cross 3 matrices. Since k equal to -1, the ones are placed one position below the main diagonal. So the generated matrix is stored in E. Then print of E. So this statement display the generated matrices stored in E. So see here the ones appear on the lower diagonal. So this was a lower diagonal. Next, we are going to discuss about identity array versus I of function. Now let us compare np.identity of and np.I of. So the np.identity of function create only square matrices, whereas np.I of function, it can create both square and rectangular matrices. Then the np.identity of function always places ones on the main diagonal. In contrast, np.I of function, it allows us to place ones on the main, upper or lower diagonal by changing the value of the k parameter. Therefore, np.I of it provides greater flexibility compared to identity array. So, both function return array with the default data type float. So, whenever only a simple identity matrix is required, np.identity is sufficient. However, when different matrix shape or diagonal positions are needed, np.I of is a preferred choice. So I hope now you can clearly understand the concept of identity array and I of function. Thank you for watching.